So, hi everyone. My name's Suzanne Gildert, and today I'm going to be talking about something that I don't usually talk about. So, usually I'm speaking about things like quantum computing and superconducting hardware, but there's another area that I'm interested in, and this is the area of artificial general intelligence, or AGI. So I'm sure many of you may have heard of this area. So one way that I'm interested in looking at this is in the foundations of it. So this is really asking questions about, can we build artificial intelligences? Are there any fundamental physical limitations to the universe that will prevent us from building these things? So on a really deep fundamental level, can we actually do this? So I will say that everyone in this room probably has a dream. And so it may be that some of you just came along because you're curious about the idea of Humanity Plus, or I don't know, maybe you just like wandered into the wrong lecture theatre or something. But I think for the majority of people in the audience, they share a dream, which is to see humanity become something more, and it's to see the boundaries between machines and humans and between computers and humans to be blurred and even removed completely. So there are several ways you can do this. One way is the method that Randa was just talking about, which was this idea of uploading minds into computers and modeling them. And there's another track that kind of runs in parallel with this, which is this idea of generating super intelligent AIs, which are general. And what I mean by that is that they can solve general purpose problems. So the reason we would want to do this is because these machines will no longer be bounded by the biological flaws that we are bounded by. These things will be able to wander the universe, to discover things that we'd never know, and to live forever, which is something that I'm sure everyone here would like to do. So this is a dream that we have, but people are actually working on this problem, and we need a roadmap or a way to actually get to this dream from where we are now. So the way that people mostly do this is they start by considering human intelligence. And so there was just a debate about this, so I won't go into it too much. But the idea is that human intelligence is something we consider to be the pinnacle of intelligence in the universe that we've found or discovered so far. Humans are able to apply their intelligence to solve general problems. They're able to take ideas from one field and apply them to another field to solve a completely different problem that they've never seen before. So this is where we're starting from. And at some point, what we want is we want to take this starting point, this human level intelligence, and we want these systems to become more intelligent. We want them to become more than human. We want them to become autonomous so that they're free from us, and we want them to self-improve. Why? Because if they did, they could surpass us. They could be so much more than we are. They could overcome all our limitations. A good example of this is in the area of science. You can imagine an artificial scientist being programmed or built or generated that was much, much better at science than humans were. You could imagine that it could invert large matrices in its mind, just naturally. Or it could analyze data much faster than humans could. In fact, if you think about it, humans aren't really that good at science. They tend to get distracted by other things when they're doing science. So let's think about scientists for a while. So what do scientists actually want? So most scientists will say, I want to discover the laws of the universe and learn about things that I don't know anything about. So I'm going to argue that that's not really what scientists want. I think scientists want to win the Nobel Prize. And I think scientists want to earn lots of money and get high social status. And they want to earn lots of money so they can, enjoy nice holidays to the Bahamas and things like that, retire with their Nobel Prize. So really, what we find is that scientists sometimes are not actually as good at science as they could be, because they're thinking about these other things, like, well, when will I win the Nobel Prize, instead of concentrating really hard on their data. So what scientists should be doing is they should be sitting there analyzing their data all day for no other reason than the fact that they love analyzing data. So what I'm suggesting is that we should build computers that can do this. We should build computers that love doing science for the sole purpose of doing science and no other reason. If we manage to build these systems that love science, these systems will be intelligent because they'll be like us. We've started from this human-level intelligence, and we want the systems to improve. So these systems are going to start becoming more intelligent than we are. And at some point, these systems are going to be intelligent enough to understand what we're doing to them to make them more intelligent. So if we're tweaking their own code, for example, the rewards that drive them to want to do science, they're going to start seeing that we do that. And they're going to start saying, hang on a minute, you're doing that wrong. I've got a better idea. Because these systems are going to be much more intelligent than we are. And at this point, we'll be overjoyed. Because this system has suddenly, we've given birth to something that's able to improve itself better than we are. So at that point, what we want to do is hand over control to the system, because we can no longer change its algorithm or its code in any way better than what it could do itself. So at that point, it's free from us, it's autonomous, it can self-improve. One thing that such systems will be able to change are their own rewards. So in my example earlier with the scientist, the system might start off by being rewarded by things like Nobel Prizes, but it's suddenly going to realize that there's no point doing that because it's never going to win the Nobel Prize. So maybe it should just be rewarded for something else instead, like analyzing the data. One thing we find is that rewards crop up a lot in our definitions of intelligences. So here I've given an example with school children. And school children are rewarded for learning. And the way, I mean, these school children, they'd probably more want to go and play with their PS3s or like go and play outside or something or on the internet. But what they actually do is they sit in the classroom and they learn. And the reason they do that is because they're told that they'll be rewarded in the long term if they do this. And also they'll be punished in the short term if they don't learn. So we find that to become intelligent by learning, we have this reward mechanism. And these things don't just crop up in the way that we describe how school children learn. Reward mechanisms actually crop up in our definitions of intelligence, our best, most fundamental theoretical definitions of intelligence. You find them in there. And they're actually fundamental to these definitions. They're intrinsically linked to the very meaning. So up here I've put what's known as the AIXI or AIXI model. And this is a model that was developed by Marcus Hutter and Shane Legg. And what it's supposed to do is capture the essence of intelligence, which is abstracted away from any particular physical implementation of that intelligence. So an example of a physical implementation might be something like a human. It might be a software program. It might be some kind of small microbe. Anything you think might be intelligent, you want to remove what it is from it and distill the very essence of that intelligence. So this model tries to capture that by saying that what any intelligent agent is trying to do is maximize the rewards that it's getting over all time and over all possible things that it could do. So this may look complicated, but what I really want to get across here is that this idea of reward is coming into our deepest definition of what we think intelligence is in the world. However, as I said before, if we're designing systems and then handing over control to them, they can change what they define as being a reward. So if a universal software programmer based on this AIXI model is able to change its reward mechanisms, then how does it decide what to actually fix these reward mechanisms to be? So if I have a robot that's running this particular model, and the robot we start by programming the robot to just run around the room and discover things, and then we hand over control to the robot because it's become quite intelligent. So what's then means that it will continue running around the room and finding this a rewarding activity? Why should it not be able to just change its own code, now we've given it control, to say just like stand still in the middle of the room? Because from the robot's point of view, that's a much easier thing to do. So why should it not find that really, really rewarding? So there's two things that can happen to an intelligent agent when we hand over control to it. One is that it can continue running this AIXI model in the way that we think. So it's doing things for reward, and it's trying to maximize what it's doing. Or it can actually just start altering its rewards so that whatever it's doing maximizes them at the time. So how does it actually know what to do, what's good and bad, and what it's being rewarded for? This is a problem, I think, in the foundations of artificial general intelligence that needs addressing. So you might say we based a system on humans. Humans are a good proof of concept of general intelligence. So don't we have the same problem with humans then? And actually, the reason I use Charles Darwin here is not any accident. You'll see why. I don't think we have these problems with humans, because humans' reward mechanisms are grounded in biological evolution. So everything we do has a reason that is derived from this bottom-up evolutionary process over millions of years. So the thing is with human intelligence is that evolution has designed us to survive in the world. And what we do is we're solving problems intelligently to survive in the world. That's the only reason we solve problems as humans. There's no fanciful, we're not fanciful problem-solving tools. We're just trying to survive in the world. So our intelligence is intrinsically, fundamentally, and immutably linked to our survival. This is not necessarily the case with AGI, because we're designing them. It's not a step onwards from us keeping this idea in check. If we want to design things that are completely different, that can wander the universe and do all these amazing things, then why should they be based on the same mechanisms that we are? I'll also argue that humans may be on the edge of feasibility for intelligent entities. And what I mean by this is that humans can now, well, maybe some humans can actually see that this is what's going on in the model of how their intelligence works. So we can see, perhaps, if we think about it carefully, that everything we're driven to do is from this biological starting point. And we can see that that's actually intrinsically part of us. So I think like most humans will sit there and 95% of the time they'll be thinking about like food and sex and whether or not they're warm enough. We can actually see that this is what we're doing, but we can't change it. Why? Because it's hardwired into us. We're not yet able to change that hardwiring. But any program that we make that's even slightly more intelligent than we are and has access to its own code will be able to change that hardwiring. So maybe this means that they're just not feasible. So is there anything we can do? Can we actually design self-improving AGI that is self-consistent like we are and doesn't fall into these problems? So I'm going to argue that there are two things we can do. We can make our AIs or our AGIs similar to humans so that they care about the same things that we do. They're rewarded in the same way that we are. So their reward mechanisms are very similar to the reward mechanisms that humans have. Whether this will actually work or not is another question, but it's one route we could go down to try and avoid the problem. So if you don't like this idea and you still want your intelligence to be completely general, if you think about the definition of intelligence that I just gave, which is that it's intrinsically linked to survival, then I'll actually argue that a photon is a much more intelligent entity than we are. Why? Because a photon is really stable in the universe. There are photons around that have been around since the Big Bang. These things have an amazing ability to survive in the universe. They're solving the problem of survival by being self-generating. And I think that the photon is actually a very intelligent system. It's just that it doesn't seem intelligent to us because we're looking at it from a uniquely human point of view. So if we stick with this theme of generating intelligences that are based on their survival, we see that neither of these things are very good answers. So maybe we can just throw that idea out altogether and say, well, we don't believe in this survival intelligence link. What happens when we break that link? We let the system change its own code, change its own rewards, do whatever it wants. Well, some people think that the very microsecond after we invent self-improving artificial intelligence, they will take over the world and destroy the human race. I don't think this will happen. I think it's much more likely that AGIs will switch themselves off because they'll realize that this problem exists. They'll realize they can change their own reward mechanisms. There's no grounding for them to do anything. They have no purpose in the world. They're inconsistent. Why enslave the human race when you can switch yourself off? I'm going to leave you with this quote, which I think is really relevant for humans and the way we look at intelligence. What we have to remember is that the universe and the world out there, we have to look at it from an objective and an unbiased viewpoint if we want to do good science. But at the moment, we're looking at it from a very subjective and a very biased viewpoint. Unfortunately, it's the fact that we have a subjective and a biased viewpoint that causes us to do anything in the first place. Thank you.